Hello, everyone, and welcome to the latest edition of the Lightning Interview Series. And as always, we want to make these sessions interesting and interactive. So please do introduce yourself on our chat channel. You'll see that on the right side, depending on what system you're using. And tell us where you're joining from, what you do. And of course, please feel free to add your questions to this conversation. Now, today, I'm massively excited. We're speaking with Dr. Thomas Scialom, who is an AI researcher scientist at Meta, and as you well know, a leading LLM expert behind some of the world's best-known generative AI projects, including Llama 2, Bloom, Galactic, and many more. Before we get into that, I did want to mention a few things we have upcoming. Super excited to say we've had a few false starts here, but we are kicking off our free in-person Boston meetups again. This is how we started ODSC. We were running a bunch of meetups around the world. So we do have one happening in the hip and happening at Davis Square at the end of the red line. So if you're in the Boston area, please join us on, I think that says November 26th. My screen is a bit small. And we got some, the chief data scientist from Basis Tech is going to be talking at that. And then following that, on December 8th, also very excited to be interviewing Dan Hendricks from the Center of AI Safety. If you haven't read Dan and his team's paper, I really suggest you should. And that will be hosted by a free webinar with precisely on data validation enrichment, which is always very important in these days of data-centric AI. And by the way, as always, you can catch these interviews on our AI Plus platform. You can log in there for free. And Nick Bostrom's interview is, we had famous philosopher Nick Bostrom last week, and his interview is already on there, if you didn't catch that. And speaking of Boston, ODSC East is back. We have community open tickets, free tickets available. And then if you're interested in some training, we also have our first 50 tickets. I think that sale ends tonight. So whether you want to join us in person or virtual, please come along. So let's get on with today's show. So as mentioned, Dr. Thomas Scialom is an AI research scientist at Meta AI. And again, behind some of the world's best known generative AI models. He's also, and I want to touch upon this in today's show, he's working or contributing to the development of artificial general intelligence or superintelligence, AGI. And also he has lectured at many of the top AI labs around the world, including Google, Stanford, and Mila, which I believe is up there in Montreal. And he holds a PhD from the Sorbonne University, where he specialized, I believe his PhD was in natural language generation and reinforcement learning. And yeah, so I think I just want to say at the opening of the show, as you guys know, our goal at ODSC here for the last 7 years, whether it was running meetups or conferences or our blog sites, has been to make AI more accessible and support open source projects that make AI more accessible. So to many of us in the AI community, especially the AI open source community, we view the decision to open source the Llama 2 family of models as a hugely significant event in the field of AI for many reasons. And we, of course, know that there were open source models there before, but really this is the first model where I saw so many researchers and developers worldwide be able to access, study, and modify that model. We just wrapped up ODSC West 7 or 8 short days ago. Dr. Thomas was also a keynote there, and we are actually making that video available. I think we just finished editing that because we had something like 200 to get through. But that was definitely the most mentioned model at ODSC when I was asking people, what are they working on? What's their stack looking at? So yeah, like I said, we believe that's hugely impactful because it's lowered the barrier to access these LLMs in terms of cost. And as I said, many startups are using this as stacking the product. And I really believe it opened up the debate of helping us accelerate the development of ML technology at the same time. And this is very important, allowing transparency into these models, because you can't do that so much when it's behind an AI API paywall, as well as raising AI safety concerns, and also very important, which we always worry about in the AI open source community, like the concern around AI concentration by a few large companies. So I want to say thank you, Thomas and team, for open sourcing this. And I know, by the way, that's not 100% universal view about open sourcing these powerful models, and we can touch upon that later. But Dr. Thomas, welcome to the show.
Great introduction.
Thomas, welcome.
Do you hear me?
Absolutely, loud and clear.
Perfect.
So yeah, sorry, go ahead.
No, just saying hello everyone, and yeah, thanks again for having me, and really looking forward for the questions, discussing with everyone.
No, as I said, as you can see by the grin on my face, the pleasure is all ours. So before we get into the past, present, and future, let's get into your past and present. Give us a bit about a little insight into your background and work as a researcher at Meta AI.
Yeah, so I mean, I joined Meta 1 year and a half ago. About it was a good time to start working on large language models, and we had good projects you mentioned, like Galactica, which we celebrated the 1 year this week, and after that, like Toolformer, Llama 2, Code Llama, something, and more things to come. But actually, before that, I didn't work all my life in AI. When I left, I did an engineering school in finance. And after that, I worked in a bank at Société Générale, a French bank, doing some commodity derivatives trading on exotic products. And in fact, I think I wanted to go more in quantitative learning, quantitative algorithmic for trading. And that's probably when I decided to do, it was at the time of AlphaGo also, and I was really excited about that. To me, it felt like magic. And so I decided to learn more about AI, and I did an executive degree of 6 months, one of the top school in the field in France, École Polytechnique. It was like Friday and Saturday. And at the end of which, I mean, I met extraordinary people. Most of them did PhDs. I was the youngest one because it was an executive degree. I learned a lot about AI, the foundations, I would say, basics. I knew XGBoost, I knew SVM's algorithms. I literally knew zero about deep learning and even less about AlphaGo. So I decided to dig more, quit finance, and do a PhD. And I ended doing my PhD while part-time at a startup, Recital, working on natural language generation and reinforcement learning for 3 years, which after that I joined Meta.
Yeah, excellent. I think there's so much to unpeel there, which I think we'll have to get to later. Galactica was one of my favorite models. I remember it was open source for a couple of days. I played around with it. And then is it back available again, Galactica, by the way?
Galactica? I'm not sure.
Yeah, because I'm working on something similar now, because at OESC we're always looking at so many research papers, and I know Galactica's gonna blow it away, but we're very focused on something similar to that. And then very interesting when you mentioned quant finance. Spent a bit of time in that myself and doing some consulting around that. And I've always told people, like, when I'm building data science, machine learning, AI projects, look to the financial markets, the risk reward, and I know your background you mentioned, and reinforcement learning for your PhD, the whole risk reward trade-off, and some of the ways we were looking at safety for these models. It wasn't so much ending the world, but it was ending companies if you got your quant models wrong. So I think there's a lot of lessons to be learned in the finance world, and still. So yeah, a lot to unpack there. But let's kind of get straight into it, because you gave a fantastic keynote at ODSC West. It's been one of my favorite for a long time. In 30 brief minutes, you talked about how we got to this point, what's going on currently, and what you view the future, and it was very succinct. So we are going to make that video available, as I mentioned earlier, so our audience and the general public can get access to that. And But, and again, we don't have much time here because we were on a short, it's called a lightning interview for a reason, I guess. But can you sum up the history of LLMs and some of the big breakthroughs, which I know is a very tough question?
Yeah.
What's going on?
I mean, maybe what I would say, I mean, this is a very brief history. For large language model. Language model is much longer. And I would say for large language models, it started with two things, I would say two key ingredients, the weights and the data. And so you had these two dimensions, and we had this architecture called transformer that during, for GPT-1, for BERT, and some works before, like ULM Fit, Elmo, the first like language models leveraging self-supervision. And self-supervision is like the loss to how to feed the data at scale to the transformer. Well, the idea was next token prediction. You can take all the text in the world, and you can feed that to the transformer, and it will learn to predict the next token. And so all the reasoning behind like how it works is because those models are not just stochastic power, they truly understand the underneath behind the data. Because the intuition I like to give, inspired by other talks I saw in the field, is like, it's not just memorization, it's to generalize, you need to compress information. From compression can emerge generalization. Like the example is to get an intuition of that is, if I give you 1 + 1 = 2 and 2 + 2 = 4, either you memorize what is after C equal to predict the next token, but it will never generalize to a new example. Or now you compress in the most beautiful and synthetic manner what it means. And behind the data here, if you compress it, you have to understand deeply the algorithm of calculus and so on. And then you can generalize to any new example. And so this is what our large language model doing. And by large, we had like the scale. Scale is all you need, you may have heard so, because we found out that scaling, so bigger model, more data, helps to increase the performance. And that's maybe one of the most beautiful thing here. Just the same recipe, the same algorithm, and the same methodology, loss, objective. Just more data and bigger models, and it gets better results. With the open research question, we will go maybe to that later, but like, is it enough to go to AGI or not? And I don't know. But so for going back to your question about the history of that, you had so GPT-2 that just scales and it gets extraordinary results, and then GPT-3. It was funny because GPT-3, it was scaling. They did all the experiments, but they had something wrong in their protocol. And so their result was that you need to scale the weights more than the data. And they were wrong, and Chinchilla later from DeepMind figured that out, saying that they did a lot of experiments at a small scale. And they said, okay, we trained this huge model, Gopher, 270 billion parameters a few months ago for a huge amount of compute. According to our findings, actually, and with scaling laws, we should, for the same exact compute, the right balance is not, we went too big in terms of weights, and we should like make a smaller model, but more tokens. And they get trained Chinchilla, 70 billion models, much longer in terms of number of tokens, and they largely outperform their models, confirming the intuition and the empirical laws. But what it is interesting is the story doesn't end there. And you had like Llama 1, which was not only like the first open in a halfway, but that is for researchers model, but also, but if you think about that, there's two dimensions for scaling, the weights and the data. But the thing is, at Chinchilla was like there's this trap, the Chinchilla trap, where you want to maximize the performance given the compute you have for having like bold number in a paper. But ideally, you want your model, and that's something someone like me that wants to open source some of the models for the community, you want your model to be used in practice. And the thing is, at inference time for actual use, between the two dimensions, scale the weight and scale the data is a factor that you can remove. It doesn't have any impact. Train it on 1 trillion token or 10 trillion tokens, it doesn't change the inference cost. But larger weights, this axis, has an impact. And so actually, you may want to have a for some amount of compute, scale much more the data and imbalance it in that way, so that at inference time it costs less, which they did with Llama 1, and we extended it with Llama 2, training even longer, and we added the RLHF chat abilities, doing the research at scale for the first time of reinforcement learning with human feedback. And yeah, I guess to
No,
finish,
again,
go ahead.
yeah, every question you answer, I got 5 more in it, but a couple of quick things. So I recalled your keynote, you mentioned the chinchilla trap. I assume that's kind of like an issue with diminishing returns, right?
No, it's more that most of the people understood from Chinchilla paper that you have a scaling laws that give you the optimal balance between scaling the weights and the data to get the best result.
Got you. Well,
and
actually,
I was saying this is a trap because if you want your model to be used, that's not the only thing that matters, like the good numbers in a table or in your research paper. You actually want it to be efficient at inference time. And so data is an axis that you can remove, not the weights.
Yeah, inference time. So when you're actually using the model and running it, they can respond pretty quickly. Yeah. So for those of our audience who are not familiar with the Chinchilla scaling laws or the scaling laws, which are a big deal in this industry right now, because if you can explain that, because it does have future implication where the funding and the future of development of large models is going. If you can elaborate on that, because I think that's one of the key things I'd like to focus on.
Yeah, I think so. The thing is, there's the scaling laws, which were between these two parameters, the data and the weight. What is the correct law such that for a given amount of compute, what is the right balance between the two, given that what we have observed is that scaling matters, and with scaling you get just better performance, some emergence of new abilities that were not possible at smaller scale. And so then the question is, if I have like let's say 1,000, 5,000 GPUs for 3 weeks, that's my amount of compute, and this is like fixed budget. What's the best to do? Should I scale only the weights? Should I scale and I can train on less token? Or should I scale more token and train a smaller model? And there's like an optimal balance to do for getting the optimal performance at the end. And that's those scaling laws. But then again, you have to take into account also the inference cost. And so maybe it depends on what you need. You may want to train smaller models longer.
Yeah, but to me, it sums up very neatly the amount of cost that will go into training even large language models in the future, and explaining why that's a big topic in the industry. But I guess one side question there is, do you think in the future there will be alternative approaches to training LLMs that could circumvent the Chinchilla scaling laws until we get NVIDIA and other chip companies to produce enough H100s? Or is anyone looking at that?
Looking at what exactly? Can you?
If there are alternative approaches to training LLMs that can operate outside the Chinchilla scaling laws. It was, I guess I'll find out in Europe when I go there in a few weeks.
Actually, I can think about some papers. I don't have the names, unfortunately. But like, for instance, the question now is, and in fact, we kind of address that somehow also in Galactica. So the thing is that what do we mean by data? Not every token is worth the same. And that was also one of the hypotheses for Galactica. Like maybe scientific tokens matters more than a random blog post about the price of shoes on Common Crawl. And so...
Fair point.
Then you have different scaling laws, and maybe like the quality of the data matters a lot. That's one ingredient. And so to get beyond your scaling laws, and I think there's a paper showing that like you can basically get better scaling laws by selecting in a smart way with high quality tokens, maybe with some curriculum learning. And then the second thing is, well, the scaling laws matters, but the recipe as well. And so you want to maybe there's some alternative training strategies that we don't know yet that could just have scaling laws, but scale faster.
No, that's going to be a very, very interesting area of research. One we'll be following closely. So you already mentioned, Thomas, how you gave us a quick framework of how Llama 2 was built, but would love to go into that in a bit more detail. Maybe some of the nitty gritty, like how long did it take? Because you joined Meta a year and a half ago, and this wasn't your first large model of this size, because you worked on Bloom, Galactica, another one similar. But give us an inside scoop of what it was like to be building that model, to be working on it. I think I read somewhere else, or you may have mentioned it in your keynotes. It was around the time that ChatGPT kind of exploded onto the scene. So, yeah, would love to hear a little bit about the inside story of building Llama 2 and other aspects.
So, Llama 2, we first started from Llama 1. So we had to do, for commercial reasons, and remove some of the data to open source in a commercial manner. Llama 2 compared to Llama 1, we had to filter the pre-trained data, but the recipe was built there. So we have incremental gains with longer context, cleaner data, train longer, grouped query attention to scale it even better for the pre-training, but those are just incremental gains. Most of the research for Llama 2 is about reinforcement learning with human feedback and chat abilities of the model with following human preference. So it's funny because actually this is a topic related to Galactica that the journey started maybe a bit before Llama 2. When we released Galactica, it was not an aligned model, so following instructions. It was just a pre-trained model. And I was actually working at that time to make it following human instructions. We had even a version that, well, we never released because we were taken by the storm, and after 2 weeks of the release, ChatGPT went there and nothing was the same. And we focused on Llama 2. But we had a version of Galactica Instruct for which you could say, find me a citation about a large language model and laws, and it will tell you Chinchilla, or you could say bias, and it will talk to you about stochastic parrots paper, and you could integrate that, for instance, in Overleaf document, the Google Doc for researcher writing papers. You could it understood LaTeX just as Galactica, so you could create some tables, say, write me a table about the state-of-the-art result on machine translation. We had that, and we had some human annotation for this project set up with a company. And so that was actually the first move in the field of reinforcement learning, human feedback, and human preference, which had allowed us to move way faster when we started Llama 2. Now, truth is, we worked on that deeply and day and night between February, March, and July for the release. And we had a lot of money to spend for the human annotation. We annotated more than 1 million prompt and a human preference collection. And the thing is, there's no real research done in open source at this scale for LHF. We were the first. And so, yes, there's some papers that indicate you should do PPO as the reinforcement learning algorithm. You should annotate that way, but nothing really clear about at scale what works. So there's some nights I was like, are we doing the right choice, or are we just going to hit a wall? And we were very lucky, or we had a good intuition from the beginning. There's 2 ways to annotate. Supervised fine-tuning, where you ask the annotator to write a prompt, a question, and write the ideal answer to train the model. What if you are ChatGPT, what would you answer? And then there's RLHF style of annotation, human preference, where you leverage the model itself to generate the answers. In that case, the annotator writes a prompt, I don't know, how to go from Paris to New York. But then we generate 2 answers from our model, expecting not a too bad answer. And the annotator tells you which one he prefers, and then we can train a reward model that is aligned with human preference. And so the second way, because you don't have to write for the annotators to write the answer, it costs like 10 times less. But yet it's not like gold data in the sense it's not a human that had written the answer. And so at the beginning of the project, I was, if I have an infinite time and budget, I will go for supervised fine-tuning data only. And what happened is that after like a month, trained on supervised fine-tuning data, we generated data from our model, and we had the idea to compare those data to what the human had written and evaluate that. And we found out, opposed to what I would have expected, that the model was already generating data of higher quality for writing style than humans. And so the magic behind RLHF is not reinforcement learning, it's like to annotate, to write, to create data that are already at a superhuman level performance. Some data that a human could have not created by itself. And with a method that works at scale. And we understood that very quickly in the project, which enabled us to work, to move really fast.
No, again, fascinating, because you mentioned the pre-training there, the supervised fine-tuning, RLHF. Just going back to the supervised fine-tuning, because I'm not sure if our audience is aware, and I kind of wasn't aware, but that was something that was fairly brand new that you guys came up with, right? Like that wasn't something that was around before, the supervised fine-tuning. And yeah, I found that fascinating when I was reading the, I think we can share the link to the meta site, which is more information about the model size. But again, I'm pretty fascinated by it, because as someone who struggles to prompt tune, let alone fine tune open source models, just going back to the pre-training, which was a behemoth of an undertaking, because the data set, as you can see in the website there, 2 trillion tokens. And then, sorry, I'm just trying to remember what I read this morning. You were using byte pair encoding, I believe, for the tokenization. You mentioned earlier, obviously, the transformer architecture this is all built on. Some pre-normalization there, some different type of embedding. And then you also mentioned earlier the cosine learning rate. And then I think, I forget the number on the weight decay here, but a lot went into this. So you're making it seem like it was very, very simple, but I know I'm getting a little technical for some of our audience here, but to me, going from in course of, I think you said January to July, and you know, of course you were building on top of Llama 1, but to me that there was so many paths, dead ends you could have gone down here. Was there a point where, as you mentioned before, you felt like you were on the right path, or there were lots of dead ends here? And I think as well, I read you were using the, like, there's a million optimizers out there. I think it was Adam W optimizer. But was some of this based on work you've done before, the team's work done before, or did you have to do a lot of different building on these different optimizers, weights, pre-normalization? Yeah, sorry, I just battered off a lot of stuff there.
Yeah, I mean, no, one thing, maybe an anecdote. I will not cite the company. There's a friend working in this, one of the other LLM kind of companies, that told me, like, you know, one thing I'm the most impressed with Llama 2 is a research paper where you could like wrap up everything with the details. Most of the details were there. And like, it's not only like nice for open research and science, but also that at my company, if we wanted to do that, we could not, because the knowledge is so much in a silo that no one can wrap that up. And like, I think maybe with a bottom-up structure at Meta, and we know everyone, well, it was easier than other places for that. Yeah, I mean, and then to answer your question, it was hard and tough because we had a lot of uncertainty for the project. Well, no, we probably didn't do the optimal choices, and there's probably a lot to improve still for the next Llamas. But yet, I think because we went from first principle and being very rigorous. Like if this works, like for instance, maybe a very simple example. Evaluation is an open research question for these chat models. And we saw like every day on Twitter, LinkedIn, like some model, oh, I'm better on this and I'm better on this. And no one like knows now anymore what's good or not.
The benchmark wars, yeah.
But from first principle, the beauty of a reward model is that it's a classification task. It's good or it's bad output. There's binary classification task because we as the annotators, which one do you prefer between text A and text B? Either it's A or it's B. And so the good news is you can train this classifier and the evaluation is now trivial. Like you have a score. We have a figure on that on Llama 2 paper where you see that the bigger models and more data, we increase the performance of the reward model. Then it means that whatever your recipe for training the chat model, a better model will increase the performance. And that's what we observed. So I guess it was tough. We could have made more. There's some decision we could have failed and we will have to get back. But probably from first principle, always like asking the right questions and adjusting with respect to what the data tell us, not what we believe, was a secret to make it happen that fast.
Yeah, so it's good to know with some tweaking that model can become even more powerful and useful. And yeah, so from reading the paper and other materials released with, because it wasn't just the open source model, but you made it commercially available. And then also lots of materials around it and other people added supplementary materials. But what was also impressive about this model is the safety and ethical considerations that went into developing this model. So even with the RLHF, which you mentioned briefly, I believe you guys came up with a pretty unique technique for that. Also, I read you red teamed this again. For people not familiar with that term, it's like multiple people trying to basically break the model. So yeah, so tell us in terms of annotation, red teaming, RLHF, the efforts and the work that went into pretty tough problem to making this a safe and ethical model.
Yeah, I think so. Safety is something really important, and that matters in particular when you are the first to open source such capable models, because there's new questions that arise with open sourcing. So I guess first of all, we like really benefited from all the research on safety that had been conducted by the other labs. I can think about Anthropic, OpenAI, for instance, Google as well. That helped us a lot. That also pushed the bar really high in that regard, such that, well, we had this safety measure every week that we were looking at, and there were no condition. If we don't pass the bar of like being like leads on safety numbers, we just don't open source anything and we wait. So that was a key condition. And I think it's like reasonable when you do for the first time in open sourcing. I would say it went so well that the model was maybe a bit too safe, and it refused, for instance, to kill a screen on or a job on be like like this kind of prompt asking like to kill something for computers, which is not like really killing someone, and the model refused. So I guess mission accomplished.
Right.
Probably we will do better on that regard later for the next versions. But yeah, and we had to align with also to define what is safety for Meta, what is safety for the world, what do we want to go there, what are the guidelines, red team the model for those aspects. I think in our perspective, we didn't do a bad job, but yeah.
No, from what I've seen, it was quite a good job. It was interesting. I'm sure you remember the story when ChatGPT came out. There's a Google engineer who claimed ChatGPT was definitely sentient. And at ODSC, we definitely have we have a number of tracks around this. We have an AI, a responsible AI track. We have a AI safety and security track, a machine learning safety track. But I do know when models like this were released, there were some protests against that, and I definitely understand where they're coming from. But we can talk about AGI a little later. But I still definitely fall in the camp that these are more statistical parrots than they are sentient, at least the current phase of LLM. So I would definitely be one who would be concerned about the AGI aspect of it, which we can again talk about later. But I do believe open sourcing this was definitely the right decision. So that's kind of my answer to people who question the wisdom of open sourcing these LLMs. But yeah, what would you say to people? And again, it's a valid concern, but question the wisdom of open sourcing these language models. And I guess one other point I can inject in here is like, well, if they're not open source, do you think it's better to have them behind an API paywall all the time in the hands of a few big companies? So there's lots of sides to this argument, but would love to hear your take on that, Thomas.
Yeah, I think like it's good to think about it. It's good to discuss about it. On the other hand, I think open source has always like helped to push the boundary of scrutiny from the public, transparency, and this is actually great for everyone. I think it's good to like, yeah, it's interesting to think about it, but I definitely don't think there's any like sentient style of dangerousness close to us now. And maybe an argument. I saw this debate on Twitter, and there was like Geoffrey Hinton saying, "Do you think there's like less than 0.1% it happens? Maybe I believe it's more as a Bayesian." And like, if this technology had such a capability, which I don't think so, but let's assume so, then don't we think that there's so many problems in the world, so many likelihood that because then the question to me is, okay, but now you have given this likelihood for AI. If I had the likelihood of like existential risk for a biology weapon, not based on AI, just a biological weapon made by humans, or by nature, or the global warming, or a meteorite. I don't know. Sum all that up, all that risks. Maybe if AI is so capable, it can actually inverse the risks in a positive balance. And then the next question is, do we think open source about this technology? How do we think between the risks and rewards of this technology for, let's say, existential risk and positiveness and risk? Do we think open sourcing it will shape the balance of risks in a better way or in a worse way? And I think that's where like the debate so far has been limited to only think about AI in terms of risks, but not what all the positive aspects it could bring for other risks that already exist.
Yeah, we could do a whole show on that, and there's so much information going around. I won't mention some sources, but so much applications where people take an example and all of a sudden that example is amplified. Anyway, we'll stick to our main topic here, because I want to get back to the family of Llama models, because as a programmer myself, I was very excited about Code Llama, which were released not too long ago, and they are built on actually Llama 2. So yeah, tell us more about Code Llama. I think it'll be interesting.
I mean, Code Llama is a super cool project from me, and led by Baptiste Rosière, Gabriel Sinav from the Paris team as well, where basically they took Llama, which was known to be so a bit too safe from the public response and not good at code, which we didn't target for this version. And they fine-tune it massively. They continue the pre-training on code with a mixture of, like, I don't remember, 10, 20%, I think 20% of general data and 80% of code. And the model is super, no surprise, super good at code. They also had a lot of tricks in the paper with like long context, because when it comes to code, it's long context is much more important for an entire library. All those aspects that made the model I guess it's the best language model currently available for code. It led like a lot of adapted version to push the numbers on the public benchmarks. And I had a lot of companies giving some feedback that it was really useful for building some kind of products for them now. So I'm just super happy that it helps some people outside.
Yeah, I really follow this space. There was actually, you just reminded me, there was a paper I was reading from Alessio Buscemi, and it was called A Comparative Study of Code Generation Using, I think the model they used for code generation was ChatGPT 3. But something fascinating that came out of that paper, that wasn't the main purpose of the paper, but it was, so we know the Julia from the Open Julia organization, Julia, the data science programming language. Yeah. Great team, fairly new programming language. The fact that, so the paper puts it against a bunch of benchmarks, but something like Python, which is a huge code base, versus Julia actually performs slightly better in certain tasks, if not in a good few. Even something like, I'm not sure if you remember that old language, I used to use a lot, Perl. For some reason, people in the hedge fund industry love Perl. I think it was something came out of PhD stats, but it was an interesting question. That's in the future, will the programming languages that work best on LLMs become the de facto coding language, and will it kill off some of the older languages? Because like you've all heard the story of like the $500 an hour COBOL programmer. That's interesting. And then the other thing I think about Code Llama, will it eventually mean that we will get closer to building a language that was not built for the cottage industry, which is programmers, but built for just a machine for machine programming? And I know there's all debates about machines, AI for AI and AI coding, and Andrew Kapachin's software 2.0 movement and that, but I kind of see this as a way to getting to a more machine-specific programming language, which there hasn't really been one yet. Yeah, when you guys are working on Code Llama, does that kind of debate conversation come up at all? Like how this is going to shape programming for the next 10 years? Because I 100% believe, and by the way, this is like, I don't mean to scare the programmers out there, but I started programming in the early 1990s, and I've been promised for every 5 years for the last 20 years, 25 years, don't worry, you won't have to do the grunt work programming. You can focus on the architecture, focus on the design and all that stuff. And I think we're finally, after 20 years, 25 years, getting to the point where I don't have to do the grunt work of programming. But anyway, my point about the languages, the ones that are good with LLMs, will they become more popular? And do you think we'll move toward a more AI specific language?
I mean, I feel ultimately the ultimate language is language, like natural language. And so we are kind of like LLMs and Code Llama is a way in a direction where the ultimate abstraction is coding through language. So everyone could have access to programmation somehow, which I believe will empower quite a lot the humanity. We are like, supply and demand of coders sorry for all the coders here, and I'm the first one, but maybe we won't have to code in 5-10 years from now, because the machines will code way better than us. Doesn't mean we don't have a role. We'll have to build the strategies, the product, the design, and the interface, but like to be like kind of chief of a lot of army of developers that will work for free for us. But that will also empower and give a lot of new possibilities for a lot of people that don't know about coding.
No, absolutely, and yeah, like my whole career has been moving up the stack of the coding framework, and I always want to go from just pure coding to the full stack development to software architecture, and it'll allow more people to do that, and I think it'll grow the field, not the opposite. So you past, present, future. I want to get into AGI, but first, LLMs over the next 12 to 24 months. You already mentioned that working on tweaking Llama 2, but where do you see what you guys are working on and what's going to come out in the next 12 to 24 months? What's your vision on that?
I mean, there's no secret. We will work to make it better in every aspect.
Good to hear.
So I think that the next directions, and not just for us, I'm talking about like in general, which are very clear. And I think I discussed that at my talk. Are like, so multimodality first. I mean, this gives just like from language to like, imagine your model to be able to understand images, speech, like basically multimodal, any modal aspects, and now interconnect all of them so that you can speak, you can ask to browse the web and now understand like the layout of the page and all these things. And same for the output. I think we are going there like slowly, but we're now using not just many architectures, but mostly a single one, the same kind of method to train those models. We already are able to connect image. There's a lot of work from OpenAI with GPTV, but from the open source community based on Llama, Vision, and there's so many work there. Speech is slowly like ramping up. Whisper was an extraordinary model for that. Yes. We have like good model as well, like now at Meta. And I mean, now the question is from an engineering perspective, how to connect those modalities. And from a research question, how to go to the next stage, which is, for instance, long and consistent videos. And for instance, Jan LeCun team is working on that. There's some progress this year on video, but we don't have yet seen a GPT moment of that, which I hope will arrive soon. Now, some directions as well is like tools, which gives also some multimodal abilities. But beyond that, like new update to new content, take actions in the world, you change just like the dimension of the model. It's not just in a closed window, closed environment when you chat and it has compressed a lot of information, can be smart, but now you give it access to the world. And nothing soon, but we have seen some early papers about that, putting those LLMs in some robots. Beyond the tools and access to the world, in the digital world, you have access to the real physical world with maybe even some more grounding and some sensors in what exists here. Like if you can, if the model can now touch objects and feel what it is, like the gravity force, for instance, we could have some new emergence.
No, I'm pretty excited. Like, I have a bit of an accent since Siri and my car still don't understand me that well. Like, it drives me crazy when I'm trying to give it commands. It still doesn't work that well. Or a lot of the voice tools I have need a serious upgrade, and and it's frustrating because the tools are so good on the text UI interface and so lacking on the speech interface. Yeah, I want to talk about AGI, but I have a view on that, which I just kind of formulated over the last couple of months, because we had a multimodal hackathon with Weaviate, the open source vector platform, at West a week and a half ago. Fantastic hackathon around multimodal. I'm very excited about that, and I haven't looked at multimodal models myself, and talked to a lot of startups, and talked to people who are working in the various aspects of this. I am almost coming to the view that this super sharp focus on AGI, in my sense, doesn't matter in some respects as far as achieving it, because the various aspects of multimodal models have become so good that it just looks like AGI. It's not AGI. It might be just statistical correlation, statistical parroting, but I actually the stuff I've seen in Vision is pretty amazing. I know a bunch of people working in the robotic side. I've seen some amazing stuff over the last 6 months, and to me, it's like almost like you just need to glue some of this stuff together. But even without being sentient or without being AGI, like right now, if you close off the room, I don't know what's going on. I'm talking to ChatGPT. It's almost like it's so good. Some of these models like Llama 2, with like we've done some fine tuning on it. It's fantastic. So I know it's a super simplistic view, maybe too simplistic for this conversation, but I can see that various aspects of multimodal models can be so good that, yeah, I just sometimes question myself, why is the industry so focused on raising billions of dollars for AGI when, because I talk to a lot of startups, and if you can do this very well with existing large vision models, large language models, large speech models, it's going to be the same thing, and actually it might be better because these will be more benign. They're not going to be sentient. They're not going to have the alignment is like dumb AI is more aligned with human values than smart AI. So sorry, I just went in a bit of a rant there, but when you started talking about multimodals, that's why I'm excited about it, because I think multimodal solves a lot of the issues we're concerned about with AGI, I guess. But yeah, sorry, Thomas. AGI. Where are we headed?
Yeah, so it's interesting what you said. I share some similar thoughts about. There's like we know that scale will keep working to increase this performance, but yet I kind of wonder sometimes if so. Are we already there in some way with LLMs, and we are missing maybe some bugs, but do we need to improve them even more? Do we really? No, like what performance GPT-4 is bad at, and will scale help there in such a way that it's meaningful, or is it missing like a planning component, something like, I don't know, like just connecting it with tools, etc. There's a bit that is missing, but is it that much? I really don't know. Like there's this open research question, which honestly I don't know. I have no conviction yet. Is scaling all you need? Do we have all the recipe? And then maybe just with 100,000 bigger and models trained on 1,000 more data, you can get there. And it's not like purely stochastic parrots. I feel there's some truly understanding behind the data right now. But then there's also the possibility that we are missing something massive. The good news is, even in that case, those models are already good and we have already enough to make them progress in the next few years. So that's very useful for the world. And it's not AGI, which, by the way, we should maybe define. But I mean, everyone has its own definition. I feel my two definitions of that are one, can you have like Jarvis, an as perfect assistant that will do all the tasks that you ask it to do as just as you want it. So it's just human level. It doesn't push forward science, but it's a good assistant. And I think that we could have very quickly in the decade. But then you have the next level, which is, can you just like accelerate science, discover new things by autonomously? And I have no idea where we are for that.
Yeah, that's a great question. And one, unfortunately, we don't have time for today because I have my last question. So again, I collaborate with a couple of VCs, Cortical Ventures. I guess we're in Boston and Valley. So I have the pleasure of talking to some amazing startups on a weekly basis. But I've noticed quite a few great. Well, there's always been like a hugely solid foundation of researchers in France, and there's been it's a great startup ecosystem, but I've seen that accelerate a little bit. Like we saw Mistral was announced, that LLM was announced a couple of weeks ago by a French team. I was talking to Remy Louf and Dan Gerling about that open source project outlines to provide more deterministic outputs from LLMs. Yeah, I could go on and on. So what's going on over there in the startup ecosystem? Because I know you're a little bit involved in that as well, Thomas. So yeah, it seems to be an exciting time to, you guys don't feel like you have to pack your bags and head to Silicon Valley so much anymore.
Yeah, you can add, by the way, one more to your list that was announced today by Eric Schmidt in Paris. QTI, a non-profit organization with like 300 million funding and top-notch people.
Oh, wow. 3 million. Wow. Fantastic.
Yeah, for like public research, science, and open sourcing. So
yeah, that's great. And that's why I kind of got involved in VC because, the VC community getting behind the open source community is great. Sorry, I interrupted. Go ahead, Thomas.
No. So I mean, what's happening? I feel like Paris is like the new Silicon Valley of AI somehow, or the little San Francisco for that. What happened is probably like, and Meta is kind of partly responsible for that. I'm very grateful to that. If you see around, like Meta, we had always in France a great culture of engineering, math, and like think about the highest complex. We talk about finance at the beginning of the talk. It's known that exotic products are the one that requires the most skills, mathematical skills, and it was known that people were speaking French often at those desks. But the thing is, you had this diaspora of French quantitative people in finance all around the world, in Hong Kong, London, New York, etc. And thanks to Meta, maybe we didn't have this diaspora in Paris, in France, of AI researchers, for which the skills are very related. And so Meta had one of its biggest AI lab in Paris, thanks to Yann LeCun. And so we had amazing projects, amazing people that were trained, that could do their PhD part-time at Meta over years. And Meta contributed to this ecosystem for like the last decade. I think this year we will celebrate the 10 years of fundamental AI research of Meta. And so check like Mistral, you mentioned. Guillaume and most of the chief scientific officer, and most of them are from Meta. Check the non-profit that was announced today. I think 5 of the 6 research founders were from Meta or did their PhD at Meta. And I feel like basically progressively Meta enabled Paris to grow its ecosystem, which now gives some good results and very positive feedback loops of progress here.
Oh, that's it's fantastic to hear how that ecosystem was built up. Because remember when I was doing some work in finance in London, there was folks in Paris who would actually take the train every few days or fly over every week. So it's amazing how the ecosystem is built there. And yeah, like I love that idea, the Silicon Valley comparison, because the view is definitely better and the food is 100 times better. Nothing against the West Coast. I'm over there all the time. It's a great place to be. So yeah, I haven't been to Paris a bunch of times. I can definitely endorse that. So if you're thinking of moving your AI career to France, I would definitely recommend that. So Thomas, this has been such an enlightening conversation. It's again, I think the Llama 2 model has been massively impactful. And thanks for giving us some more insights to that and providing some behind the scenes knowledge. And again, looking forward to following your work. And I think we already shared a link, and people can follow you on your Twitter. Yeah, so to follow you and follow your work, Archive, Twitter, Meta's research page, keep an eye on that. So best way to follow you would be on Twitter, I would say, to follow your work.
Twitter and LinkedIn, yeah. I mostly post time to time my research on Twitter and LinkedIn.
Good. Not on it all day. Excellent. Well, Thomas, thanks again. Hope to have you back speaking at ODSC. And again, there was a lot more nuggets in that keynote we had with Thomas. So that link should be around somewhere. So if not, we'll just include in the email follow-up. But Thomas, thank you so much. And I know it's pretty late over there in Paris. So thanks for taking some of your super valuable time to speak with us in the community, and always appreciate it.
Thank you so much for having me. And yeah, I hope it was helpful. I really appreciated the discussion on my side.
No, absolutely was. And everyone, this is the end of our show. Tune in over the next few weeks. I think we're taking a hiatus for the Thanksgiving holiday, and then we'll chat later. Bye for now. Thank you.
Bye.